Hello everyone, this is Mrs. Snook with section 1.4, Shifting, Reflecting, and Stretching Graphs. In this section, our old friends A, H, and K are coming out to play. Our objective is to recognize the graphs of parent functions and then to be able to use vertical, horizontal shifts and reflections of our graphs. So here's some common parent functions. You'll find this graphic on page 41 of your textbook. You've got a linear function, and the parent function for that is f of x equals x. Here is an absolute value function. I want you to notice that the range is always positive on absolute values. Square root function. Notice that it's only taking the positive square root. And then here is x squared, that's a parabola. That one should be pretty familiar to you. Cubic function has this little jog here in the middle, and that's the area we're going to look at when we try to figure out the transformations on that one. And then rational function, that just means 1 over x. All right, so let's look at some shifting. So first of all, I mentioned A, H, and K. So remember, H is in control of your horizontal shifts, and K controls vertical. And we're going to use the parent function x cubed for this. So I could write this as y equals a x minus h cubed plus k. Because of that negative on the h, it kind of goes backwards. H is going to shift it from side to side, left to right. If you have a minus h, that's going to shift to the right. If you have a plus h, it's going to shift to the left. So take a look at our first one. We have x cubed minus 1. So let's compare that with its parent function x cubed. So right here, in the blue, that's x cubed. The red is x cubed minus 1. And then the black is the other one, that's x plus 2 cubed plus 1. So looking at just the blue and the red, you see what happened? Blue is your parent function, and the red is shifted down by 1. So I would just call this a down 1. And that's what I expect because k equals negative 1. So I can look just at the equation, I can see that minus 1, and I know that that means that my graph is going to shift down by 1. All right, now I have h of x is x minus 1 cubed. Let's see if I graphed that one. We're going to graph. All right, y equals. I'm going to put it here in y4. And it's going to be y equals, don't forget your parentheses, x minus 1. And then I'm going to hit the little caret. That's going to give me an exponent cubed. Press enter. So this is going to be the purpley graph. X minus 1 cubed. Let's remove some of these other graphs because I think it's getting a little confusing. So I'm going to clear this one out since I don't need that one anymore. I'm going to clear this one out. I'll put it back in a minute. So now here's our parent function, and here's x minus 1 cubed. So you see how this little bend here, it shifted to the right by 1. This is h equals 1 because of that negative in there. So kind of think of that as change the sign. I had a student one year that said normal flip normal. Normal was A. You didn't do any weird changes for A. K, you have to, H, you have to flip the sign on. So since that's a negative 1 there, H is positive 1, and that says you're going to go to the right one. And then when we looked at the graph, it did go to the right one. All right, our last one is x plus 2 cubed plus 1. So let's make a prediction before we look at the graph. We have a plus here. So now h equals negative 2 because you flip that sign. K is 1. So what I should see is a left 2 and then up 1 shift. So now let's go to the calculator and let's do that graph. I'm going to clear that last one out. And remember your parentheses, x plus 2, close your parentheses, and now raise it to the third. And I think it was a plus 1. Let me double check, make sure I put that in correctly. Yep, I got it. Let's hit the graph, and now let's compare. So right here, that's where it crossed the y-axis. The blue one's the parent. Now that same part is right here. So we went 1, 2, 3 to the right, and then up 1. Sorry, did I make that? I said right, it's left. Let's go back and take a look at that graph again. So from here to here, 1, 2, left 2, up 1. And that's what we expect from our prediction. All right, so this is just a summary. And I took this out of your book. They use C's on here. Just remember A, H, and K. And what they're saying here is if you take your parent function and you add or subtract C, adding it is going to move it up, subtract moves down. And then here you put the shift inside the parentheses. So this is vertical. And it's outside the parentheses, it's on the end. And then horizontal is inside the parentheses. So the next thing we're going to do is, using the graph, we're going to write the equation. The parent function for this one is x squared. It's a parabola. This is our parent graph. Now I'm going to take a look at A. I have the same parent, so it's still a parabola. And what's happened is this parabola has moved up. It moved up 1, 2, 3, 4. So g of x is going to be my parent function, which is x squared. And since I had an up 4 shift, I do a plus 4 on the end. Now I've got a, let's see, we went 1, 2 to the left. So that means that k is going to equal, sorry, did I say k? H equals negative 2. And then we have a down 1. That says that k equals negative 1. So when I write this equation, this is h of x. H of x equals, I've got a left 2 shift. That's going to go inside the parentheses. Change your sign. H was minus 2, so it's going to be plus 2. And then k goes outside, minus 1. There's your equations. Okay, now we're going to look at another one. Finding equations from graphs. So take a look at this g of x. Our parent is still y equals x squared. Now look what's happened. It's upside down. I call that a flip. So what this means is I've had my parent function and it flipped over the y-axis, so reflected over the y-axis. When that happens, that means A is negative. Because here's what A governs. A governs flip. That happens if it's negative. It also governs stretch or compress. And today we're focusing on the flip, on reflections. So for my g of x in this picture, I know I have a flip, so a has to be -1 because of the flip. Also, my vertex moved up 1, 2, so I have an up 2. That means that k equals 2. So when I write this equation, g of x is going to be -x squared, because of the a is -1, that gives me my flip, plus 2. Okay, now look at the other one. Here we have a flip. I have a flip, therefore a equals -1. And I went to the right by 3. My vertex was here at the origin. 1, 2, 3. This is a right 3. That means that h equals 3. So when I go to write this equation, h of x equals negative. Now we have a horizontal shift that goes inside your parentheses. Change the sign. It was a +3, so I'm going to do -3 squared. All right, so on your calculators, graph y equals x squared, and then y equals -x squared. So put this in y1, put this one in y2 on your calculators. Pause the video here, and then you can compare your graph with mine. Did you get this? The graph on top in the blue, that's y equals x squared, and the one on the bottom is y equals -x squared. So you can see the symmetry right here is the x-axis, and literally this blue parabola is reflected over the x-axis to give you the red parabola. All right, so now we're going to do the same thing we've done, but this time we're going to use the square root function. So now our parent function is y equals square root of x. I'm going to show you that on the calculator. We're going to clear that, and we're going to do y equals second square root, second square root of x. Right. So this is what our parent function looks like. Now what if we put a negative in front? So this means a equals -1. I should see a flip. It should flip over the x-axis. So let's graph that and see if it flips. So on your calculator, we're going to go into y equals, come down to y2, and we're going to do a negative square root of x. Graph that. So there's your flip. Now what happens if the negative comes under the radical there? Where is that going to reflect? It's not a is -1, so it's not going to reflect over the over the x-axis. So take a look. Let's see what happens. I'm going to clear this one. We're going to do second square root of -x. Look at that. It flipped it over the y-axis. That's a horizontal reflection. All right, last is k of x. We have negative square root of x plus 2. On here, a equals -1. So that's going to give us a flip. And then k, I keep saying k, this is h. H equals, change the sign. So it becomes a -2, which means it's going to shift 2 to the left. All right, let's compare on our calculators. And before I was saying that if it's horizontal, it goes inside the parentheses. This type of function doesn't have parentheses, it has the radical. So inside the radical. So look, we had a flip. See, it's flipped over, and you can very easily see that this anchor point that was here at 0 for the blue graph is over here at -2. So let's reflect on what we've learned about the reflections. If you have the negative in front of your function, that's a vertical flip. If it's inside, that's a horizontal reflection. All right, that's it for today's lesson. Thank you for watching. Have a great day.